Now, the next chapter which we are going to do is rational numbers. Before we start rational number, let us revise once more all the patterns of numbers. So first are natural numbers, which we have already studied. That numbers I am talking. So natural numbers are represented by n, and the set contains 1, 2, 3, and so on numbers. So all the numbers greater than 0 are called natural numbers. Then next type of numbers are whole numbers. And it is represented by a capital W. They are equal to 0, 1, 2, 3. All the counting number or natural numbers when added in the group with 0, they are called whole numbers. Then next comes integers. And integers are nothing but negative infinity, -3, -2, -1, 0, 1, 2, 3, and it goes till infinity. So all the positive and all the negative numbers, including 0, forms integer. Now comes next rational numbers. Rational numbers are the numbers which can be written in P by Q form, where P and Q are integers and Q should not be equal to 0. The reason why Q is not 0, because I can say 1 upon 0 is infinite or not defined. So we can't find 1 upon 0, so that's why Q should not be 0. Leaving 0, you can put any positive, any negative number in the numerator as well as denominator. Here, P upon Q, P is numerator and D is denominator. So in denominator, it can't be equal to 0. Leaving 0, you can put any value of Q and any value of P. Here, if I take P equal to 0, so that will be a rational number because 0 upon 1 is a rational number. So I can say 0 can be written in the form of rational number. Now one basic question comes, can I show any whole numbers as rational numbers? So, and he is asking us to justify that. So I can say yes, as 0 upon 1 or 1 upon 1 or 2 upon 1, like that you go on doing, are all rational numbers. Now let us discuss some of the properties of rational number. First one is closure property. Now here also we will have for all of the operators, that is addition, subtraction, multiplication and division. So first for addition, if I say, that means here it is saying let A and B be any rational number. So when I add, I will get a rational number. Let us discuss that. Let me take A as 1 upon 2 and B as 1 upon 3. So if I add A plus B, I will have 1 upon 2 plus 1 upon 3. So here directly I can't add, so I will do LCM. LCM of 2 and 3 will be 6. So 2 threes are 6, so 1 threes are 3, and 3 twos are 6, so 1 twos are 2. So my answer came as pi upon 6, which is a rational number. So I can say it is written in P by Q form. So therefore, rational numbers are closed under addition. Now, if I do for the subtraction, now let us take again two numbers. A minus B should be a rational number. Now, A equal to 1 by 2, B equal to 1 by 3. So, A minus B will be equal to 1 upon 2 minus 1 upon 3. So, again the LCM will be 6 and 3 minus 2. So, this came as 1 upon 6, and 1 upon 6 is a rational number. So, therefore, rational numbers are closed under subtraction. Then, next is multiplication. Now, here it says A into C should be a rational number. So, again I am taking A as 1 by 2, B as 1 by 3. So, A into B will be 1 upon 2 into 1 upon 3. So, 1 ones are 1 and 2 threes are 6. So, that is a rational number. So, therefore, rational numbers are closed under multiplication. Now, let us do for division. It says A divided by B should be a rational number. Now, here it may happen or it may not happen, because if I am taking A equal to 1 by 2 and B equal to 1 by 3, so then it will be possible. See, A divided by B will equal to 1 upon 2 divided by 1 upon 3. So that is 1 upon 2, either I divide or multiply with reciprocal. So this is 3 upon 2. So this is a rational number. But if I take A equal to 1 upon 2 and B equal to 0 upon 1, so then 1 upon 2 divided by 0 upon 1. So either I divide or I multiply with the reciprocal. So reciprocal will be 1 upon 0. Now this will be 1 upon 0. So then it is not a rational number. So here I can say, therefore, rational numbers are not closed under division. See why I said not closed, because if I take the reciprocal and it is coming 0 in the denominator, it won't be possible. Now next is commutative property. So here also again we have to do for all. So commutative property says that for addition, A plus B should be equal to B plus A. So now let us check. Example, A equal to 1 by 2, B equal to 1 by 3. So A plus B will be 1 by 2 plus 1 by 3, and B plus A will be 1 by 3 and 1 by 2. So LCM in the both the places will be 6. Now here two threes are 6, so 1 threes are 3, plus 3 twos are, so 2 ones are 2. Here the same way 2 plus 3. So I am getting pi upon 6 equal to pi upon 6. So therefore commutative property is satisfied for addition. Now same way if I try for subtraction, so according to the method it says A minus B should be equal to B minus A. But this won't be possible anytime, so it won't be satisfied. Now again A equal to 1 by 2 and B equal to 1 by 3. So here I will have 1 by 2 minus 1 by 3. Here I will have 1 by 3 minus 1 by 2. So they are not equal. So from starting I am writing not equal. 6. LCM in both the cases will be 6. And here it will be 3 minus 2. And here it will be 2 minus 3. So 3 minus 2 will be 1 by 6 is not equal to minus 1 upon 6. Therefore, for subtraction, commutative property is not satisfied. Then same way, if I check for multiplication, now here the property says A into B should be equal to B into A. Let us check. A equal to 1 by 2, B equal to 1 by 3. So this side I will have 1 by 2 into 1 by 3, and on this side I will have 1 by 3 into 1 by 2. So this will be 1 upon 6 and this also will be 1 upon 6. So they are equal. So commutative property for multiplication is satisfied. Commutative property for multiplication is satisfied. Then comes for division. So here it says A divided by B should be equal to B divided by A. But this is next to impossible. It can't be possible that 1 divided by 2 will not be equal to 2 divided by 1. So same way I am taking A equal to 1 by 2, B equal to 1 by 3. So A divided by 2 will be 1 upon 2 divided by 1 upon 3 will not be equal to 1 upon 3 divided by 1 upon 2. So 1 upon 2, either I divide or multiply with reciprocal. So 3 upon 1, 1 upon 3 into multiply by reciprocal. So here I am getting 3 upon 2, which is not equal to 2 upon 3. So commutative property for division is not satisfied. Commutative property is not satisfied for division. So now let us revise once more closure property. Closure property for addition, subtraction and multiplication, it is satisfied. Division, if 0 comes in the denominator, it is not satisfied. Now commutative property is satisfied for addition and multiplication. For subtraction and division, it won't be satisfied. Now, associative property for addition says A plus B plus C should be equal to A plus B plus C. See, here I have to check BODMAS rule also. Okay, here first in the LHS it is shown B and C are in bracket. So that addition I have to do first. And A plus B in the RHS is in the bracket. So that addition I have to do first. Now let me take A equal to minus 1 upon 5, B equal to 2 upon 5 and C equal to minus 3 by 4. I am taking three numbers and checking. So here if I do LHS I will get minus 1 upon 5 plus in bracket 2 upon 5 plus minus 3 upon 4. And on the RHS I will have minus 1 upon 5 plus 2 upon 5 plus minus 3 upon 4. So let me check. So this will be minus 1 upon 5 plus. Now here 5 and 4 are there, so LCM will be 20. So 5 multiplied by 4 is 20. So 2 multiplied by 4 will be 8 plus into minus minus. Now 5 threes are 15. Now here it will be LCM will be 5. So minus 1 plus 2 plus into minus will be minus. So I am putting from the starting only. Now minus 1 upon 5 plus. Now here 8 minus 15. So sign will be minus. So it will be minus 7 upon 20 equal to minus 1 plus 2. So that will be 1 upon 5 minus 3 by 4. Now LHS, the LCM will be 20. So 5 fours are 20. So here minus 4 plus into minus minus and 7. And this side I will have LCM 5 and 4. So 20. 4 minus 15. So here I got 11 up minus 11 upon 20. Here also I am getting minus 11 upon 20. So therefore, for addition, associative property is satisfied. Now, for subtraction, I don't need to check because already commutative property is not satisfied. So here also it won't be satisfied. We know that. So I am not doing that. Now for multiplication. These two properties will be only satisfied for associative. So for multiplication, again, here it says A multiplied by B multiplied by C should be equal to A into B into C. So again, A we have taken as minus 1 upon 5, B I have taken as 2 upon 5, and C I have taken as minus 3 upon 4. So here I will have minus 1 upon 5 into 2 upon 5 into minus 3 by 4 equal to minus 1 upon 5 into 2 by 5 into minus 3 by 4. So here minus 1 upon 5 into, now if they are getting cut, I have to cut. So 2 ones are, 2 twos are. So this will be minus 3 by 10, and on this side it will be minus 1 into 2 will be minus 2 upon 25 into minus 3 upon 4. So 2 ones are, 2 twos are. In the next step I will get cut. So minus into minus plus. So 3 upon 50, and here minus 1 into minus 3 will be 3 upon 25 twos are. So 50. So I can say therefore associative property is satisfied for multiplication. Again, for division, it won't be satisfied because if I divide, it won't come the same. So we are not doing that now. Next is additive identity. So additive identity. It says if I am taking A as any rational number and if I add something in that, I should get back A. So that is identity element will be for addition, it will be 0, right? It will be 0 because when I add 0 in any of the number, so I will get identity. So I can say A plus A plus 0 equal to 0 plus A, which is equal to always A. So 0 is my identity for addition. Now, if I talk for multiplicative identity, that means in A I am multiplying something to get A. So 1 will be my identity there. If I multiply any number with 1, I will always get the same number. So A into 1 equal to 1 into A, which is equal to always A. So 1 is identity element for multiplication. Now coming to the next property, that is inverse property. Now inverse property, what it says, for addition A plus what I will add, that I get identities. And for multiplication, it says A into what I bring, so that I get 1. So it is clear that in A I have to add minus A to get 0. Opposite of that, like if I take suppose 1 by 3 as A, so if I add minus 1 by 3, I will get 0 here. So minus 1 by 3 is inverse of 1 by 3 for addition. So I can say that for addition, inverse of A is minus A. If it is minus A, the inverse will be plus A. Now, same way for multiplication, if I multiply 1 upon A, I will get A cancel, so I will get 1. So like that, 1 upon 3 into 1 upon 1 upon 3. So that will be 1 upon 3 into 3 by 1. And then 3 cancel, so I will get 1. So therefore, for multiplication, inverse of A is 1 upon A. That means reciprocal of the number I have to write there.